Welcome back, students. So in the previous lecture, we discussed about the hot working process. So hot working process is the process which is done. It's a type of metal working process which is done above the recrystallization temperature. So what happens in a hot working process is that the grains become elongated due to the application of load and due to the application of heat, that is above recrystallization temperature, the grains get dissolved and smaller grains are formed. So this is a process of hot working process. So same thing happens in a cold working process except the recrystallization temperature. It is done below the recrystallization temperature. So what happens here is the grains get elongated due to the application of load, but new grains are not formed. Only these elongated grains are available. So what happens here is that these stretched grains, they have a property called as residual stress. The residual stress is because of the application of load. So once you apply load on a material, it gets stressed. Stress is nothing but resistance to deformation. So that resistance builds up inside the material. So what that residual stress does is it increases the hardness of the material. So in the plastic deformation theory, at the beginning of plastic deformation, in the stress strain curve, we have noted that strain hardening takes place. That strain hardening is nothing but, I said it's also called as work hardening. So because of the work hardening, what happens is that residual stress builds up inside the material. That residual stress causes the material to enhance its hardness. So as you see here, because of the residual stress, what happens is that the strength and hardness of the material is increased because internal stress builds up. That causes the increase in hardness of the material. It is suitable up to a certain extent. So anything which is good can be good up to a certain extent. If you overexert that, then it becomes a problem. To take exercise working out also for yourself, you do to a certain extent, it will be beneficial to you. But what happens if you overwork yourself, then you become fatigued, some cramps or even fracture, muscle loss, muscle tear may happen. Same concept with the metal also. If you work the metal up to certain limit, it increases its hardness. But if you overwork the metal, then crack propagation, fracture may happen. So cold working is done in particular way so that the internal residual stress enhances the hardness and strength of the material. So another important thing here to note is close surface dimensional tolerance. So because of the application of heat in the hot working process, I said we cannot control the change in dimension. But here hot working, there is no heat and hence the change in dimension can be closely monitored. That enhances the acceptable tolerance. Close dimensional tolerance can be maintained compared to the hot working process. And the major advantage of this cold working process is that surface finish is improved. Since there is no deposition of carbon because of the application of heat, the surface is smoother compared to the hot working process. That's a major advantage of this cold working process. So disadvantage, as I said, if you overexert the material, distortion may take place and also much higher working pressure than hot working because in the hot working, you are heating the metal. When you heat the metal, it becomes softer. Softer materials require lesser load to deform compared to older materials. Sorry, normal materials. So hence, cold working process requires higher load or higher working conditions compared to the hot working process. So that's a major drawback of this hot working process. So how to maximize both hot working and cold working process? So I will give you a particular case study. Your aim is to produce a material with high strength and high hardness. That can be achieved by first subjecting the material to hot working process. So when you subject the material to hot working, what happens? First deformation happens, then new grains are formed. So those new grains improve the ductility and strength of the material. So again, when you subject it to cold working, what happens? The surface finish of the metal improves and also its hardness improves. So by performing cold working process, after hot working, you can enhance the property of the material. So any metal which requires high strength, precision, and accuracy, they are subjected to first hot working and then cold working process, which improves the property of material. I hope you understood this hot working and cold working process. We'll see in the next lecture video. Thank you.